Hello. Welcome to the Charlottenburg Institute of Technology in Berlin.
Hello, yes.
Are you here for your interview?
Yes, I am.
All right. Now, what is your name and how old are you?
My name is Fritz Haber. I am 23 years old.
Date and place of birth?
I was born in December 9th, 1868 in Breslau, Silesia, Prussia.
Good. And your religion?
Jewish.
Jewish.
Little did Haber know that this would be an enormous problem later on in his life, and it would shatter his heart to realize that the country he had dedicated his science to would despise him.
Okay, thank you. Welcome to this university.
Thank you.
From 1981 and up until the Great War, Haber published great works on chemistry. In 1896, he published experimental investigations on the decomposition and combustion of hydrocarbons. In 1898, he published the theoretical basis of technical electrochemistry. In 1910, he published the electrolytic process of organic chemistry, written in collaboration with Alexander Moser. These works still have huge impacts today, such as providing a scientific basis for developing the pH meter, concepts that we take for granted. However, the greatest of all his works is undoubtedly the fixation of nitrogen. Ammonia for a global food crisis was emerging.
People, in another 30 years or so, the bread-eating peoples of the world, already 5.6 million strong, will be face to face with a wheat famine of the direst description. The deficit is already formidable. Reserves are already exhausted, and bread eaters must be fed from current harvests, and the wheat growing area is strictly limited. Or, to put the problem in a less terrifying form, how is the average to be increased from 20 to 101 bushels? Starvation may be averted through the laboratory, but by a wholesale application of nitrogen fixation, the dominant nature of wheat. Nitrogen-based fertilizers are becoming scarce, despite the fact that there are practically an unlimited supply of nitrogen in city sewers, soils, and in the atmosphere. We must, everybody, through the use of chemistry, find an industrially applicable way to produce nitrogen fertilizer.
I believe I heard you ring the doorbell.
Yes, I have a letter for you, sir, Mr. Haber. The Österreichische Chemische Werke of Vienna invites you to investigate the synthesis of ammonia from its elements due to the shortage of nitrogen fertilizer. Of course I will. Hey, Robert Le Resignol. Look at this publication by Walter Nernst. Ah, yes, pull up a stool. Show me. Have you found something? He says that he was able to synthesize ammonia under 30 to 57 atm. He's the first to synthesize ammonia under pressure. You know, a while back, I gave up on a project on having to try to synthesize ammonia from its elements, but I think we should start off where I had left off. I see. All we need to do now is to find a way to synthesize ammonia more efficiently, use less energy, produce more. And Nernst's publication here will help me continue. I see that right here. Yes, yes. Hello, my name is Dr. Carl. So, what do you have to show me today? So, this plant is able to synthesize ammonia from elemental nitrogen and elemental hydrogen. And this is a huge breakthrough because we have an abundance of nitrogen in the atmosphere. It is the most abundant gas in the atmosphere. Of hydrogen, true. Hydrogen too, yes. So, now we are able to take elements and synthesize ammonia efficiently and effectively so that it can be applied in the industrial sector. Alright, that's good. Now, show me what you've ever started with. Okay, so you start off with elemental nitrogen and hydrogen in its gas forms. And then it is in a tube. And then it goes through a compressor. And then after compressed, these gases, still in gas form and not in liquid form, are going to go into the reactor, which is the heart of the reaction. Now this reactor has two chambers. It has an outer chamber and an inner chamber. So first the gases are going to go through the outer chambers. And then after passing through the outer chambers, these gases are going to enter the inner chamber, in which first it is drastically heated up in here, heated up to reach the necessary activation energy. And after reaching that activation energy, it will then meet up with some catalyst beds, which mostly consists of iron. And then thus, the reaction having reached the activation energy is going to occur. And then ammonia is going to leave through a tube over here. Ammonia. And of course, remnants of the reactants, nitrogen and hydrogen. If you want more in detail about this reaction process, so it's going to start off with nitrogen plus hydrogen leads to ammonia. And of course, iron is going to be a catalyst. And now, the genius of this apparatus is that it is able to create enough heat for the reaction to occur. And part of the reason is because there is an outer chamber first. So this reaction, the synthesis of ammonia, is an exothermic reaction, which means a lot of heat is released. So in the heart of the reaction, in the inner chamber in which the reaction is taking place, heat is going to be released, and this heat is going to inevitably seep into the outer chamber too. So as the elemental nitrogen and hydrogen are going through the outer chamber, they are already getting heated up, and thus contributes to achieving the activation energy necessary for the reaction to occur. And now, moving on, over here, once the ammonia and elemental nitrogen and hydrogen are out here, it goes through a cooling chamber, and from extremely hot to cooler. And of course, these are gas form, all three of these over here, because it is extremely, extremely hot. Over here, it gets cooler, and after being cooled, it's still not a liquid yet, it condenses. And this condensation process is two parts. The gases go through a tube that spirals like this. And then, after spiraling, well, there are two processes of this condensation. First of all is a cooling process to make it clear. And the cooling process occurs by making cold water enter here and making warm water come out here. So there's a continuous circulation and supply of cold water to cool these gases and not to condense. And second is pressure. Is that as these gases go through this spiraling tube over here, increased pressure will be applied to them as the tubes get smaller and smaller, which means that by the end, ammonia. Yes, liquid ammonia drips into a chamber down here. Now, where does the excess reactants, excess nitrogen and hydrogen go? Well, they are going to go through this tube over here and actually go back into this cooling system because the heat released from the ammonia can be used then again to reheat nitrogen and hydrogen gases so that they will be all warmed up and ready to be used up again in this reaction chamber over here. Is that clear, Dr. Karl Bosch?
This is it. This is the solution. We've done it. We've discovered it. Now, tell me again. How much ammonia does it produce?
It produces 100 milliliters of ammonia every hour. Extremely efficient.
But soon Haber's scientific achievements turned darker, for the commencement of World War I brought a darker purpose for his scientific brilliance.
Mr. Fritz Haber, today our country calls you to your duty. Our country, our soldiers, they need anything that can help them in combat. Whether it's irritants, gas, anything, we need your help. Chemical warfare. Of course, nothing can match my patriotism to this country, Germany.
Chlorine gas was deployed for the first time in Ypres, France, in April 1915. The world would never be the same again. The age of chemical warfare had begun, and Fritz Haber was Germany's chemical warfare service chief.
The year is 1918. It marks the consummation of this great war. Let us forever remember this year, for this will be the year in which the war that ends all wars will have been fought. However, we must move on, move past this terrible year, and look with pride at the scientific achievements of this century. Welcome, Mr. Fritz Haber, who will be awarded the Nobel Prize in Chemistry for his ammonia synthesis.
This was Fritz Haber's golden days, having just proudly served his country in the war and having just been awarded the greatest honor in the scientific community. Haber was bursting with pride, but that would not last.
Is this one of those Nazi race laws again? Yes, it is, sir. ID, please. Do you know who I am? I'm a professor at this institute. I teach here. Sir, I need your ID. Ah, Fritz Haber, the Nobel Prize winner, is that correct? You must all be out of your minds. I am a loyal citizen of this country. Look, I converted back then. Look at this crucifix. I was born a Jew, but I have converted. I have been loyal to my country. You do not understand my contribution during the Great War. Look, sir, I'm only going to tell you this once. You have to leave, go to England, and never come back. What? Excuse me, sir, can I please see your ticket? All right, thank you. Hello, sir. Is this seat 2E? All right. I have lost all. I have lost my first wife. I have lost my country. Germany is a dead weight, sinking in a sea of debt. I tried fruitlessly to extract gold from seawater, but I have utterly failed to serve, and my country no longer wants me. Conductor, he's having a heart attack. Somebody,